In this video, we will generate the dataset of this function 1 plus x to the power b quantity raised to the power c and its Taylor-Maclaurin series sum using combine and permutation functions. Here our value b will be from 0 to 8. Data validation, list of items 0 to 8. And the value of c is also data validation, list of items 0 to 8. And you can start with 1 here and 1 here. So we generate the dataset. So our array formula, the quantity 1 plus x to the power b, the quantity raised to the power c, and enter. And we generate the Taylor-Maclaurin series sum of this. So it is the summation of a times x to the power bn, where the value of a is combination or permutation, and c is from 0 to, and n is from 0 to c. This will be sequence c plus 1, 1 column starting from 0, incremented by 1. Right now our value for n is 0, 1. Increase that. Increase c at c equals 2. The value of n is 0, 1, 2. At c equals 3, the value of c is 0, 1, 2, 3. And the permutation. So this is our first coefficient. So this is permutation coefficient, permut of c comma n, c comma n, divided by the denominator is factorial n. So factorial n, and enter. So if this is empty, this should be 0. We'll correct this. So our value of n is from f3 to f11. So we have a condition at if our value for n is equal to 0 or empty, then 0. Otherwise, calculate. Now it's corrected since these values are 0. We continue with the combine function, which is equal to array formula combine c comma n. And enter. If this is empty, it should be 0. We'll also correct this. So we copy this condition preceding the function and replace this first part of the function. And enter. Now it's corrected. Now we can complete the Taylor-Maclaurin series sum expansion, which is array formula series sum of x raised to the power bn, where bn starts from 0, because at n equals 0 it's 0, incremented by b. And the coefficient, you can choose combine or permutation. Let's start with combine. Enter. And we chart this. Insert chart. And we use scatter chart. Use row 1 as header. Customize series. Trend line is polynomial to the 8th degree. For the label, we use the equation. For the legend, position at the bottom. And here you find the trend line and polynomial. Our polynomial shows the Pascal triangle coefficient 1, 3, 3, 1. You calculate these values using the LINEST function. You start with the matrix. So this is equal to array formula of the x values raised to the power 0 to 8. Now we can use the LINEST matrix to calculate the polynomial regression coefficient. So LINEST, starting with the function itself, data y and data x. And the expansion, LINEST, data y and data x. And here you have the polynomial. We'll compare. Let's compare the polynomial regression coefficient. Coefficient of x to the 0, 1. Coefficient of x, 3. Coefficient of x squared, 3. Coefficient of x cubed, 1. Let's go back to 1. So here we have the coefficient of x to the 0, 1, x, 1. Increase that to 2. So this is our Pascal triangle coefficient x for x to the 0, 1, x1, 2, or for x to the power 1 or x and x squared 1. At c equals 3, Pascal triangle coefficient will be 1, 3, 3, and 1. Suppose I change this to, instead of the combination, I will use permutation. Will I get the same result? Let's find out. We'll use the permutation. Then enter. The polynomial regression coefficients are the same, and the polynomials are the same. The data sets are the same. If we go back to 1, that's the same polynomial. The Pascal triangle coefficients are the same. 2, 1, 2, 2, 1, 1, 2, 2, 1. At n equals c equals 3, 1, 3, 3, 1, 1, 3, 3, 1, 1, 3, 3, 1. 4, that's 1, 4, 6, 4, 1, 1, 4, 6, 4, 1. Suppose I go back to, I change this to 2. And change this to, go back to 1 or 0. Okay, we'll go to 1. So you have 1, 0, 1, 1, 0, 1. At c equals 2, that's 1, 0, 2, 0, 1, 1, 0, 2, 0, 1. 3, that's 1, 0, 3, 0, 3, 1, 0, 1, 1, 0, 3, 0, 3, 0, 1. So this completes the use of combine permutation to generate the expansion, Taylor-Maclaurin series expansion of this binomial 1 plus x to the power b quantity raised to the power c.